So hello everyone. Today we will be going through our project real-time monitoring of water distribution system. So what my project is to detect water leakages at different locations or to detect whether some impurity is being mixed with the water that is being supplied through pipes. So what we do is that we take readings at different houses through different sensors, and then we send those readings through using Apache Kafka to a centralized node, which then over which we perform certain aggregation tasks to see whether the total output is equal to the total input at various houses. If it's not, we declare it as an anomaly. So that's our basic project. So let's go through it one by one. So first part of the process involves data generation. So for data generation, we define certain features of our data set. So some of the features are sensor ID. Like we have different houses to from which where we are getting readings. So each sensor ID defines that house. Then timestamp, the time at which readings were taken. Secondly, we use flow rate as a measure of the total amount of volume going through each house. Then we use pH and turbidity. These is also important because pH and turbidity can tell us about the cleanliness of the water. If there is mm, some leakage at our location, the water can get impure. So these readings also help us to detect an water leakage or anomaly in the water distribution system. So these are certain features of my data set. So now to simulate sensor readings, we need to generate a synthetic data set. So I have decided various distributions from where I would be picking these values. So for flow rate, I have decided normal distribution because for normal distribution usually fluctuates around the average value and which occasionally spikes or drops. Similarly, for pressure, I have chosen log normal because the distribution is very unlikely to be negative because of the pressure values. Because in physical world, pressure values are positive. Also, for similarly for pH, I have taken normal distribution because pH of a neutral water is 7, and we would like to simulate from a normal distribution with mean 7 and a small standard deviation to simulate real time pH ratings. So we will be moving on with the code. So this is my code for sensor data generation, and for each sensor we generate some data, and for then which we store in a data frame. And this is the code for generating for a particular sensor. Through this code we generate for multiple sensors. Then moving on, we what we do is we try to visualize our data. So as we have noted how to generate our data and what are the characteristics of our data, it's very important to visualize our data. So next what we do is we create a dashboard to visualize our data. So uh, let's create the data set first. Now we have been created, these are some top rows of our data set. Then we create a dashboard. So this is my water monitoring dashboard. So first plot contains the time series through which we can plot time series for different features of our data set, such as pressure. Then we can plot for pH. Similarly, in this same only we can select which feature we have to plot. Suppose we do not want to plot for flow rate, or we want to see for temperature, this we can plot. Then we can change from which sensor these data are coming. In this way also, this plot is an interactive plot which tells us at what timestamps the readings were taken and what were their particular values. Similarly, in this dashboard we also have these box plot and histogram to see what kind of data we are simulating. So for flow rate I have chosen normal, so the histogram tells that the distribution is normal or the data is normally distributed. Similarly, box plot can be very helpful to detect outliers or to see in what range our data lies. So this is what all we have done for the data visualization part. Then for this sensor reading, since we try to simulate multiple houses, what I have done is to select what sensor we have to focus at a particular time, and then you can monitor those sensor characteristics through these plots. So for timing, I will only be simulating three sensors for my demonstration, but you can simulate as many sensors as you can and create data accordingly. Now moving on to the next part. So next part involves training the data and testing for anomalies. So basic ML models, I have used some basic ML models to detect anomalies. First one is isolation forest. So what isolation forest does is it simply introduces anomalies in the data by taking some points as anomalies and most of the points as normal data points. So then it trains a random forest and classifies data accordingly. So while using these isolation forest, I was getting a accuracy of 0.88, or that's 88% accuracy. Then what I have detected, what next method I have used is k-means. Since we do not have a labeled data because we are trying to simulate the process, so what I have done is to use clustering, where I would cluster some points in a normal data set and some points as anomalies. So I have trained k-means, since k-means requires some hyperparameters which is k. What I have done is, for my project I have selected some values of k and tried to check which one performs the best. So my accuracy was 86%. And similarly for this, selecting k and threshold, if a point lies outside this radius of the centroid, then it's an anomaly. So these all hyperparameters are highly domain dependent. Then the third technique which I have used is Mahalanobis distance for multivariate uh, outer outlier detection. What Mahalanobis detection do is that we cannot simply depend on one feature to detect anomalies. Sometimes in the underlying system there can be small variation in pH but not in the flow rate, so that cannot be detected only using the flow rate. So what I have done is I have considered all the features at once and tried to detect whether there was an anomaly or not. So through this, I was getting a accuracy of 91%. Moving on to detect anomalies, I have used two approach. Those are through a threshold base, that is some domain use those threshold are those threshold I get through some domain knowledge. And second, I have used this Mahalanobis distance approach for detecting outliers. Now getting to the uh, real time data streaming and classification part. So how can we really send our data and visualize on the backend is through Kafka. So what I have done is simply created this Kafka consumer and producer. So Kafka producer sends our data to a centralized node through to Kafka consumer. So this is done through this code. And this can be simply we train these models here. Then we first train, I will also be sending these models to my other notebook because I try to use those models there. So through this Kafka we can also send these models to our another notebook. Then so these are my three models, which is clustering through k-means, Mahalanobis distance, and isolation forest. Then we set up our Kafka producer. So for setting up our Kafka producer, we need to run these commands. Then now, since this indicates our Kafka is getting is running on the back end, so now I can send my data and receive on the other end. So to simulate these two end processes, I have created two notebooks, which through in one notebook I will be receiving the data from the other notebook. So let us first receive the model that we have created, which is this one. So I run it here, and as soon as I send from there, it gets received here. So let's send the data. So this says send, and here we receive our matrix and covariance, which shows our data is received on the other end. Now we try to send some of our data to detect anomalies. This only simulates a real time process. So as soon as we send readings to the centralized node where we perform aggregation and do certain ML modeling and detect whether there was an anomaly or not. So through this code we can send data to the other notebook. So what we does is, here this is an interactive Kafka producer where we can decide what certain features of each certain characteristics of each feature we want to test. So for example, if we are drawing flow rate from normal distribution, we this notebook asks us to decide the mean and variance. Similarly, for pressure, now we can also select the number of data we want to send. Since we are only simulating the process, we do not want to send infinite number of data, which usually happens in real time, but we will be only sending around 100 or 150 number of data messages to our Kafka consumer. So on clicking this button, these data will be sent to the Kafka consumer, which is here. So as soon as I start this Kafka consumer on the other notebook, it gets started. So here it displays this real-time turbidity and flow rate monitoring system. So here now, as you can see, nothing is being displayed. But as soon as I start to send data points are being registered there, and some aggregation from multiple sensors are being calculated, and those data points are sent, those data file points are classified as anomalies or not. So let's send the data. This data is being sent. So as you can see, one of the points was above the threshold, so it detected and just plotted on the real-time monitoring dashboard as above threshold. So we can see there was an anomaly, or we can alert the system to check that data point or that at that timestamp. Similarly, there was a point where we got a point below the threshold. This is for our flow rate. Similarly, I was also plotting turbidity to see whether there were some impurities getting mixed with water or not, to check our water maintains a good turbidity. Similarly, now this was being done through a threshold. Like we have some domain knowledge and we set certain thresholds. Now, what if we want to combine all the features together and try to detect an anomaly? We can also do that, which is being done through, like we can do that through Mahanovolo's distance. What it does is it takes into account all the features and tries to detect anomalies through doing clustering in higher space. So now let's run this data. Let's run the another part where we detect our anomaly through Mahanovolo's distance. So yeah, it gets running. So here also we display a real-time turbidity and dashboard, turbidity and flow rate dashboard with anomaly detection. What it does is, as soon as the data point is contains some anomaly, starts to detect that anomaly. So let's say we were sending through a 100 flow rate mean. So as soon as send the data here, these points are getting registered and being shown. So since you can see there are no anomaly because we were sent, there is one anomaly, but mostly there are no points are detecting an anomaly, and we can say our model is working good. We also can see when turbidity is between a certain range, we are not getting this anomaly. But as soon as I temper the characteristics of different feature here, the we can see those anomalies getting registered there. So let's say if I change the turbidity to wait a minute. Let's say I change the turbidity to 1.5 or 1.6, 1.3. So as soon as I send data, the data being getting registered there will start to show anomaly. Since so let's see what are the values. I am getting 1.164 values. So these, as you can see now, anomalies are getting detected. I am marking the anomalies on this main chart where I am plotting the flow rate. But as you can see, the we do not temper the flow rate, but we tempered the turbidity. So this system detects the changes in turbidity also. So we can simply detect water leakages through flow rate or fluctuations, but also we can also detect water impurities. Sometimes the water pipes get broken, or there is some collision or some construction getting going on, because of which water pipes get damaged and water gets impaired. So we can also detect this through our water monitoring dashboard. Now this is all what I wanted to show through this demonstration. uh, let's go through our report for once. So reports include all those parts that I have done. First was the data generation part. Then from what distribution I have drawn different characteristics of the data. Then data visualization part. I have used a real-time dashboard to visualize different features of the data. Then I have trained certain models to detect anomaly. First one was isolation forest. Second one was k-means, and third one was clustering through Mahalanobis distance. Then I used real-time Kafka, real-time data streaming and classification with Apache Kafka. What it does is it simply takes readings from the sensor at different houses. Then it sends those data to a centralized node where we aggregate the data and try to classify the data as anomaly or not. Then we plot this real-time data with on a dashboard, and if that data shows anomaly, we also mark that point, which gets marked over this dashboard. Through this, we can easily detect water leakages and water getting impaired. So that's all. Thank you.